Hi friends, welcome to our channel. Today we are going to look at problem 3678, smallest absent positive greater than average. So this is an easy problem, but in this video our main purpose is to show the importance of understanding the requirement of the problem. So here we are given an integer array called nums. So we want to find the smallest absent positive integer in nums such that it's strictly greater than the average of all elements in nums. So if you look at the constraint, so the nums can be negative, right? But what we want to return is the smallest absent positive integer. So this is an important assumption. So in my first try for this problem, actually I ignored or didn't notice this point. So therefore cannot accept, right? So with that said, let's quickly look at the three examples. So here in the first example, the two numbers are both positive. Their average is 4, right? But above 4 we have 5 and 6, but 6 is not here, so we return 6. And in the second example, the first two items cancels, get 0, and the sum is 2. 2 over 3 is given by this one. So above this you have 1, 2, 3. So 3 is the one we need to return. Well, for example 3, so the average is 1.5. So 1.5 above you get 2, right? 2 is not here, so we return 2. So that's the overall problem. So here, if you look at the first constraint, so the length is bounded above by 100, and therefore this is a small size problem. So we can quickly solve it just by direct logic. So now let me first get the n and the total. So n will be the length of nums, and total will be the sum of nums. So this way we can compute the average. So average will be the total divided by n, right? So here this division is actually going to give you some float number, right? But what we want is smallest absent positive integer that is strictly greater than, right? That's the average. So therefore, so we can start from here. So we can from the start is going to be, so this, if this average is not integer, so we want to make it an integer, but we want to find the smallest not strictly greater than this one, so we need to add 1. But another requirement is positive, right? Therefore we want to do this max this one with respect to 1. In other words, if this guy is very negative, right, so we need to start from 1. Then we can write a while loop, or you can write a for loop, it does not matter. While true, so what we want to check, so here actually I can make a auxiliary set because essentially we want to check memberships. So if start, this is an integer, right, not in auxiliary set, so we are going to return start, right? So otherwise, so we just need to increment the start by 1. So this way, because of the size of the problem, it will, at most you iterate say 100 iterations, you will get the result. Let me try to run it. Yeah, it passes the 3 test cases. So now you can submit that. Yeah, it passes all the cases. So this problem is a small size and direct logic problem. So this is the full code. I'm not going to do more on this problem. Thank you for watching.